All right, we all know already that I is the imaginary number and it is equal to the square root of -1. It's a handy thing that lets us solve, for in our case, quadratic equations that would otherwise not really have a solution. But there's some other things that we can do with I, including raising it to exponent powers. So the first one, I squared, I to the second power. I, all by itself, has a power of 1. But if we do I squared, well, what that means is we're taking I, which is the square root of -1, and we are raising that to the second power. Now, because the square root operation and the squaring operations are opposites, they cancel each other out, just like addition, subtraction, multiplication, and division. We end up with just -1. So I squared is equal to -1. Cool. Keep going. I to the third. We're going to have to start using some things we know about exponents already. Well, I to the third power, we can sort of break that up. We can break it up into I squared times I. Well, I squared, we already figured out, that's -1. So this becomes -1I, or just negative I. Cool. So I squared, I to the third. Let's do I to the fourth. And this is actually going to complete a little pattern that we'll eventually see. I to the fourth, again, using some exponent rules, I to the fourth is I squared times I squared, because you would add the exponents in this case. 2 plus 2 is 4. Well, that's really -1 times -1, which is 1. And just to kind of complete this one up here is just I. So these 4 things right here are all the possible values of I when we raise it to some exponent power. These things actually start repeating. If we do just the next few here, I to the fifth, using our fancy exponent rules, it's I to the fourth times I to the fourth is just 1. We just saw that. So this is 1 times I, it's I, right? Starting to repeat this pattern. I to the sixth is I to the fourth times I squared. I to the fourth again is 1 times I squared, -1. So this just is 1 times -1, -1. And you can see it's starting to repeat. It's going to keep going. I'm not going to keep going through them, but we'll do some examples to see how we use this to, figure out even higher powers. So let's look at an example of an even higher power, like, let's say, I to the 13th power. Well, this one right here is going to be the key for us. I to the fourth being 1 is awesome, because anytime I multiply something by 1, nothing happens. I can pretty much ignore it. So I'm going to break this down. 13, 4 goes into that 3 times. So I to the fourth times I to the fourth times I to the fourth. That is 4, 8, 12. That's 12 i's. Close. We need one more. So this here is going to be 1 times 1 times 1, which is 1, doesn't do anything, times I. So I to the 13th is just equal to I. And I'm always going to use this little trick. I'm always going to see how many 4s go into the number and then what's left over. In this case, there's only 1. So it's the same thing. It has the same value as I to the first power, which is just I. Let's do another one real quick. I to the 34th power. A little bit trickier. 34. How many times does 4 go into that? Let's see. 4, 8, 12. So 4, 8, 12, 16, 20, 24, 28, 32. So that's 1, 2, 3, 4. That's 8 times. And we need 2 more to get up to 34. So I to the 4th, I to the 4th, I to the 4th, I to the 4th. 1, 2, 3, 4, 5. That's only 20. We need a couple more. 24, 28, 32, and then 2 more. Let's count that again. So that's 4, 8, 12, 16, 20, 24, 28, 32. All of these are just ones. So all of this is just 1 times 1 times 1 times 1 times 1, 8 of them. We end up just getting 1 times I squared. Multiplying by 1 again doesn't do anything. So we just get that this is equal to -1. Because it's going to have the same value as I squared, which we already talked about, equals -1. Last example. I to the, we'll go a little smaller. That was a lot of i's to count out. Let's just do, let's do 19. All right. How many times is 4 going to 19? Let's see. 4 times would be 16. So, and then that's 3 left over to get all the way up to 19. So, 4th. That's 4, 8, 12, 16. We need 3 more, so I to the 3rd. There we go. So this right here is all 1. 1 times I to the 3rd. We just get I to the 3rd, which is actually -I. -I. We only honestly care about this little remainder. So we could do ridiculously high powers of I if we can just find out kind of how many 4s go in and then what the remainder is. Let's do that really, really fast. Let's do I to the 803rd. Now, I already know that 4 goes into 800 nice and evenly, 200 times. But we have a remainder of 3, so this thing is going to have the same value as I to the 3rd as that remainder. I'm not going to write out 200 I to the 4ths because that would take a long time. It's the same thing as I to the 3rd, which we just know is -I. Cool. Hopefully that was helpful.